Good morning, and thank you so much for joining Fox Valley Metrology along with our partners from Mahr for today's webinar. It looks like we have a few people still joining. We're going to add a couple more minutes on here until it's 10 o'clock, and we will be starting promptly. Thank you. Good morning. I just want to thank everybody for joining us today for our Basics of Measurement with our partners here at Mahr. I would like to introduce you all to George Schultz. He is joining us today from Providence, Rhode Island. He has 40 plus years experience and a lot of knowledge that he is willing to share with us. So thank you again, George.
Well, you're welcome.
I am Jane Kern. I am one of the marketing team members, and we also have Amy Voigt, who is joining us today as another marketing team member. We are happy you are all able to join us. I know taking time out of your busy schedules. A little bit of Fox Valley Metrology background. We are an ISO 17025 accredited lab, proud to specialize in calibration, repair, and new equipment sales. We have 27 years of business in our background and currently 7 locations in the US. We hope to be adding to those this year and excited to be sharing those forward in the coming months. A few background participation tips that I'd like to share with you all is everybody is on listen only mode, but if you do have questions, I'd like you to make note of the Q&A box on the left side of your screen. You are able to enter any questions there throughout the webinar, and Amy will be checking over those, and we will review those at the end to just help with anybody's concerns, questions, and so forth. I'm also happy to share that the webinar is being recorded. All attendees will receive a link in a couple hours after the completion, and you can review, share with team members at your convenience. Another site that you're able to check for this webinar, along with other webinars that we have in the past, is our YouTube channel. Please feel free to check that at your convenience. And don't forget to follow us on Facebook and LinkedIn. If there's nothing else on my end, I'd like to turn it over to George. And thank you again for being here today.
Well, good morning, everyone. Thank you for attending today's webinar, and thanks for the introduction, Jane and Amy. What we're trying to do today is just give you a little background about the basics of measurement. Measurement's always a fun topic for me, and but really we have to think about what's really happening to make a good measurement. So what we're going to do today is talk a little bit about what the measuring process is. We're going to learn the difference between measuring and gauging, and we often use those two terms interchangeably, but there really has some difference to them. We're going to take a look at the performance capabilities of the different measuring and gauging instruments out there. And then we'll look at some of the enemies of making precision measurements, because nobody wants to lose any microns during their day and maybe drop them on the floor and slip on them as we're walking by. So we have to keep those microns under control. So what is the measuring process? I think the measuring process is more than just a number from a sensing device or measuring unit. You know, we talk about 5 degrees Fahrenheit or 30 inches long, or basically what we have is a number and some standard unit, either be inches or millimeters or degrees or whatever. But really, to get that number, there's a logical sequence to the operation used to perform that measurement. And this sequence is a process, and I think that process consists of at least 5 different elements, each one which has its own influences. So if you look at this photo here, this is one of our operators out on the shop floor at Mahr that is measuring some, I think these are bezels for dial indicators. And if you look at this picture, how many different elements make up this measuring process? So let's take a quick look at and see if we can find them. The first one we have is, in this case, we have a standard. This is a master ring, which we have to have some type of reference to begin our measurement with. Then we have the workpiece itself, the part that we're measuring. The instrument or the gauge or the tool that we're making the measurement with. We need to have an operator, somebody making that measurement, or the people involved. And finally, what surrounds us here is the environment, and the environment sometimes is the biggest influence on the measuring process. But one thing that's fun to remember is that, you know, easy way to remember things is by an acronym. And of course, you can see what the acronym is here. It's SWIPE. The measuring process consists of 5 different things, which we can remember them by thinking about SWIPE: the standard, the workpiece, the instrument, the people, and the environment. And a little cheat sheet that we like to use in the gauging world is that you can see that the instrument, the eye, is only 1/5 of the measuring process. So a lot of people call up and say, well, you know, your gauge isn't working right. But our technicians are trained to look at the whole measuring process to make sure that there might not be something else influencing the instrument to produce the inaccurate readings. So if you can remember SWIPE, I think you can go a long way to improving the measuring process. Now let's take a quick look at these 5 parts. The standard is the master. It could be a gauge block, a master ring or disc, some pins. It could be the internal scale that's inside the micrometer or the caliper or the length measuring instrument. But the standards, they all have to be clean. We like them to be the same material as the part, all stabilized to room temperature. You should know that they've been certified, and you know what the size and form is. They're in a good condition, no burrs or rusts or nicks on them. And usually these standards are made to some international designation of a DIN master or an AGD ring or whatever the ANSI standard is for these standards. The same characteristics also apply to the workpiece. You know, it should be clean, same material as the master and the gauge, in good condition. You know, you want to keep it clean. Any burrs, oils, grime from the machining process should be cleaned off of it. It should be temperature stable, which means, you know, if it's some process that produces a lot of heat in the part, you should give it a minute or two to stabilize, to get the temperature down. You should understand the form and the finish of that part and how they can affect the measuring process. And you should be aware of any special characteristics of the part. You know, is it a thin wall, or is it a compressible material? What's the surface finish of it? All of those things can affect the measuring process. Just here's an example of how geometry can affect a measuring process. As you know, most micrometers or calipers or two jet air plugs, ID fixed plugs, and so forth are two contact systems. And they're great for measuring parts which have an even number of lobes, like the picture on the left upper there. You can see that has a major and a minor diameter, or an even number of lobes. So that 2-point contact system is going to do a great job measuring the smaller or the larger diameter of that part. But if you have a part that has an odd number of lobes, in this case 3 lobes, that 2-point contact system is not going to do a very good job of measuring the part. It's going to produce the same diameter anywhere as you rotate that gauge through the part. So it's important to understand that what your form of your part is, to ensure that you have the proper gauging system for it. We can make a 3-point measuring system. So these are items that, for example, you're making two parts, an ID and an OD, and they're not fitting together, even though the gauges say they are right. It could be a form error causing that problem. Let's take a look at the instrument. Usually the tighter the tolerance, the capability of the gauge, the more mass it has. So bigger is better when it comes to gauge stability. It should be mechanically sound, everything's tight, uh, appropriate for the tolerances being trying to be measured. The gauge should be repeatable, have the proper resolution, make it as simple for the operator to use with as little operator influence as possible. Sometimes instruments are made to a standard, especially if you're measuring compressible materials, they should be made to the proper gauging force, contact diameter, etc. And that type of gauge takes into account any special characteristics of the part. Now, the part can have surface and form errors, and form and surface errors can show up with air gauging, for example, because with an air gauge, we use back pressure to measure the diameter. And if that surface is too rough, the gauge can actually think it's measuring further down into the surface than the peaks. Whereas a contact gauge on the right here measures only the peaks. So again, it's important to know the surface of the part as it affects the gauging, which can affect the gauging or the measuring process. So tight tolerances, we need to know what surface finish is. The people are an important part of the gauging process. You talk about people in a measurement center or a lab somewhere. You want a good, even temperament, emotionally stable. You want them to take pride in their work and be perfectionists, have some good judgment, a good sense of humor, because typically a measurement lab is in the back corner of a facility somewhere. 3 or 5 people might be working in there all day long doing, their measuring tasks, and it's a close environment to work with people. But even in today's world, operators are also being asked to become inspectors and so forth, and they need to have some of those characteristics. I like to think that a good source of inspectors and people working in measurement centers are people who come from submarines. They probably have the same skills. They work close quarters. They're doing life and death situation types of activities. I think they have a great skill to become a dimensional lab technician. And then finally, part of the measuring process is the environment. And sometimes it could be the largest contributor of measuring errors, especially in submicron types of measurements, because you want that lab or that area of measurement to be a constant temperature, no air flowing, causing different gradients of air of temperature around. You want the humidity to be controlled where it's not too damp to cause rust, but not too dry to be uncomfortable for the user, free of vibration, and of course, free of dirt. So you have to take good care to make that sure that your measuring environment is proper for the tolerances of the parts that you're trying to measure. So by knowing this measuring process and understanding swipe, I think you can get a better understanding of each element, how it can affect the process, where those sources of errors are. Maybe you can use the operator to find some of those sources of error. It can help you troubleshoot questionable readings, and I think it can improve the measuring instrument to make its influence on the process as small as possible. Now let's talk quickly about the difference between measuring and gauging. And often these terms are used interchangeably, but there really is a difference between them. Measurement is a process of determining a dimension of a part by comparison with a standard, usually an internal standard. So it's a direct reading instrument. Whereas gauging is a process of determining whether a dimension is smaller or larger than the standard. It usually has an external standard, so it's an indirect reading instrument. So measuring instruments use an internal scale and measure the part comparing to an internal standard. They have the standard built in. They're relatively slow and require more skill of accurate measurements. They are versatile and can measure a wide range of dimensions. And they, because of so much operator influence, they generally have a greater measurement uncertainty. So what are measuring instruments? These have the scale built in. These are things like micrometers, calipers, hand scales. These are all measuring instruments. But you can get good results from a measuring instrument when they're dedicated to the process, like height gauges. You can make universal measuring machines, which have some very high performance, and you can see there's a lot of mass involved with that. And you also have shop floor length measuring machines. So these are measuring instruments. They have the scales built in, and they're measuring the part with that internal scale. Now, gauging instruments are a little bit different. They determine whether the dimension is smaller or larger than a predetermined standard. So they have an external standard. It could be a gauge block, it could be a ring or a disc. Now, these gauges tend to be a little bit faster and more accurate than measuring hand tools because they're more dedicated to the task. So, and I think gauging instruments can also be defined into different levels of performance. First, you have your adjustable variable gauges. These are things like an adjustable bore gauge. They have lots of adjustable range, but once you adjust them to a specific size, they have relatively short comparative measuring range. They're adjusted to a specific size, limited measuring range. They can provide the actual deviations. With an adjustable bore gauge, the operator has to sweep through the part, so they have some operator influence. So it takes some skills, but you can get good results. They require a nominal master for setting. They tend to be, kind of more expensive than a caliper, for example. But if you can maintain them, and they can last decades with that. And because they give you the variable information, you can learn more about form, process trends, and diagnose manufacturing issues. So these are some of adjustable variable gauges. Typically ID adjustable bore gauges. Some ID OD gauges are also variable gauges where you have to swing through the part to get the dimension that you're looking for. Then we have the adjustable variable gauges, but they have a reference built into them, or a backstop. So again, they're very similar. They have adjustable range, a lot of adjustable range, short measuring range, but because they have a backstop, the operator doesn't have to rock the part to make the measurement. The part kind of just locks into place. It's very easy for the operator to use, no operator influence, and you can get some very good results. And these gauges also can last decades, and they give you variable information, which is very important to diagnose manufacturing issues or control the quality of your part. So these are adjustable variable gauges with reference, your snap gauges, your bench I, the OD gauges, even a height stand with a backstop will improve the measuring process. Then we have our fixed variable gauges. These are gauges like a fixed plug bore gauge, an air plug, air ring, and so forth. These are made to a specific size. They're the most accurate, no adjustable range, short measuring range, but they're the fastest and easiest to use, least operator influence. They can give you a lot of good information about your process. And especially if you're measuring a lot of parts, this is the way to get the best results from from the gauges and your whole measuring process. So our Dimentron plugs, our 844D ID plug gauges, air gauging, these are all fixed variable gauges made to specific size, but fastest and best results. You get some hybrid gauges in there. That's a little bit of combination, and we do that. But these have some operator influence, and it's like I said, it's a cross between a variable gauge and a fixed plug gauge with some intermediate results. But you can classify, your types of gauges and your needs based on tolerances, speed of measurement, operator influence, performance, and you can kind of make yourself a matrix of, based on those things, which might be the best gauge for your application. So which one do you want to use? Well, you can lay that chart out, and based on accuracy, cost, time, ease of use, and so forth, which one might give you the best results, and which is the right one for your measuring problem. And then we can take a quick look at some of the enemies of precision gauging. It's a measuring war out there, out in the shop, and we want to do the best we can that the enemy doesn't influence our measurements and try us to steal our microns and rob your gauges of their best performance. So what are some of the enemies of precision measurement? Well, where's a big issue with gauging or measuring? You have worn contacts, you can have worn body diameters, you have worn anvils. The workpieces should always be fully positioned under the measuring contact. And when the contacts are worn, you can get an offset or a deviation in your measurements, especially with measuring instruments. If you have some wear in a gauging instrument, since you're comparing the part to the master and that contact measured both the same way, it's less of an influence, but it still can pose a problem. So consider wear as a potential enemy for stealing some of your gauging performance. And using the different type of masters compared to the part can pose a problem. Here's a grossly worn snap gauge, for example, that's been used measuring a round part, and that round part has put a little bit of a indentation into the anvils. Now, if we use a gauge block to master that gauge, well, you can see the offset that's going to be there based on that gauge block. However, if we use a master pin or something, you probably wouldn't see that offset. So different masters and different work pieces can cause you deviations in your measurement. This is one of my favorite pictures. We make gauges that are IP67 rated, and we can dunk them in a coolant tank and they're still going to work. But that still doesn't take away from the fact that the parts have to be clean, the gauges have to be clean to make accurate measurements. So just because a gauge is IP67 rated for liquids and dirt does not mean that it can measure in these conditions. You should wipe the part, you should wipe the anvils of the caliper before you make your measurements. And that's the same with any gauge. So dirt's a big problem. Looseness is a potential problem. You know, when you look at a height stand such as this, you have numerous joints of contact. You have the column going into the base, you have the arm attached to the column, you have a fine adjust, you have a backstop on the indicator, which is attached to the adjustable, the fine adjustment. You have a contact point. All these things, if they're not tightened, will be loose and they'll show themselves as non-repeatability in the measurement. So every day, before an operator uses a gauge, it should be checked for looseness to make sure that everything is tight, so that looseness will not influence your results. Deflection is something that's kind of hidden out there. You know, whenever building a height stand or any type of gauge, you want to keep the arms and all the points as short as possible so that there's no influence of deflection in any of the gauges. So you can see here is a picture of a stand with a very kind of a skinny uh, arm on it, and you can imagine how if you touch that arm, it's going to deflect up and down. So if you can shorten that up, you'll get less influence on your readings. And the same thing applies when you're using a caliper or a micrometer. Some people have real strong hands, and some people might not have such strength in their hands. So you want to make sure that you apply a gauging force that's good enough to make contact, but you don't want to force the anvils onto the part where you possibly can deflect the reading of the gauge. And gauging pressure on the part can be a big influence. Like I said, when you're compressing or measuring compressible materials such as paper or some Teflon or something like that, the weight of the gauge will compress the material and influence. So there are standards out there where you can define what the weight of the dead load weight of the contact should be, what the diameter of that contact should be, so that everybody has the same gauge. And if that part is measured anywhere within the world, they're all going to get the same results. So we have to watch out for gauging pressure sometimes. And like we talked before, the environment is a big source of error. You can't just sometimes put an air conditioner into a room and assume you have good enough temperature to make precision measurements. Everything influences the environment. Lights, bodies, hands, drafts, they all influence the environment. That environment relates to the part, and that can cause that part to grow or the gauge to grow or shrink based on the temperature. So watch out for the environment as problems. Vibration can be a problem, especially when making surface finish measurements. Typically a surface gauge is used on a granite surface plate, or a precision one might have a vibration isolation table. But you can have forklifts driving by, or your company might be next to a highway or something, and vibrations can get into the measuring process when using a surface finish gauge. Especially a gauge that's doing a skidless measuring system. So it's good to check to see what the vibration is, and you can often do that by making a measurement on a part, but not tracing it. Just let the probe sit there and watch what the probe sees. If you see a lot of vibration, then you probably should take some steps by putting some isolation pads or finding out where that vibration is coming from in order to get a good surface gauge result. Some gauges can have geometry errors. If the contact is not moving perpendicular to the measuring surface, or the anvils of the snap gauge are not parallel, um, you know, you can get a cosine error, you can get flatness error. All of these things can affect the gauging process. We talked about the form errors before with 2 or 3 point measuring systems. We have to keep our eye out for this. So those are some of the enemies of precision gauging. But if you can check your gauging before you start your day for some of these problems, and as you go out, go through the day, you can verify. You should verify the zero position occasionally, based on the number of parts and the criticality of the tolerance. It's good to put the master in the gauge or bring the micrometer to zero to make sure that nothing has shifted during the day. You want to clean the gauge with dirt occasionally to make sure that there's no dirt from the part getting onto the gauge. You might make sure that the master and the workpiece are at the same temperature, and make sure that the masters are under calibration control and your certifications are up to date. And like I said, you should, on a daily process, inspect the gauge for wear, loose components, dirt, and so forth to get the best measuring results out of the gauging process. So I think by knowing the enemy, you have a chance to defeat it. We have in today's seminar, I think we've learned what the measuring process is, understand that there are reasons for measuring and gauging and which one to choose. Uh, it's good to match the right gauge or measuring instrument to the application. And we always have to keep an eye out there to keep our measuring process at its peak. So I'll let Amy or Jane take over, and if there's any questions out there, we can take a look at them.
Thank you, George. Great presentation today, as always. So we know we can um, rely on you guys and Mahr for all of your expertise here. I don't believe we have any questions that have come through at this time. Of course, I will give it a few more minutes while we kind of review everything else that we have here. But again, it is on the left-hand side of your screen. You can answer any questions you may have there. As of right now, we are excited to share that we have some upcoming webinars. You can reach them at our website at foxvalleymetrology.com about webinars. We have a few coming up this month. Next week, we have proper care and use of calipers and micrometers. I apologize. The following week, we have proper care and use of calipers and micrometers on Tuesday, and on Wednesday we have maximizing your gauge management, how to get the most out of Fox Valley Metrology, and February 14th is Master Metrology 360, our free online gauge management system. And I'm just going to skip back over to our Q&A. It looks like a couple of them came through here for questions. So George, the first one we came across was, they jumped on a little late. Is there a way I can get the recording? As I had mentioned for this, we are happy to share that after the webinar is over, all attendees will receive a link for the webinar. So you are able to access that at your convenience. Again, we also have the feature of going to our YouTube channel. We will be sharing this on our channel in the next couple of days. So you will be able to see that, share it, review it, whatever your needs are for that. And again, if you guys have any questions, please feel free to reach out to any of us at Fox Valley Metrology. And the other ones were the same. They jumped on a little bit late. I do have one, George, that says, where could we find the gauge pressure chart?
I'm sure if you searched on, I mean, if this is related to some industry of measuring some types of films or so forth, usually that industry will have an organization that's related to them that have all types of charts related to that specific device. But like I said, it could be some type of film or rubber or any of those compressible materials, they will give you the deflection charts, and they'll also recommend the various standards that the industry recommends for gauging pressure and gauge design. So I think that's something that you can search through the industry, and I think you'll be able to find that.
Okay, thank you for that. I did on the side here look up, there seems to be many different pressure charts. And again, if it's something that you're not able to find, please feel free to reach out to us and hopefully we can help with that. And I do not see any other questions that came through, so that means you did a fabulous job, George.
Thank you. Good.
Yes, I would like to share our referral program. Jumping ahead to Fox Valley Metrology here. We are very proud of what we do, our services, and hopefully you guys are as well. Our referral program is a benefit that we are, we provide the best possible experience for you guys. So if you are appreciating what we do, spread the word and refer businesses to us, and we can do the rest. So you get to tell a friend completes the service, and you get $100. So it's a great way to, pad your pocket and share the great experience that you're receiving from Fox Valley Metrology. Again, all of these can be linked to our website. So if you have questions, please feel free to look out there or reach out to any of us at Fox Valley Metrology. And regarding anything else, we do appreciate everybody taking the time to join us today. I know everybody is busy, and it's just another way that we like to share, some of the knowledge in our partners. Mahr always does a great job. We're so happy to have you available, George. So thank you again.
Thank you. You're welcome.
All right. And with that, we hope to see you at our next webinar. Thank you, everybody, for joining today.